Okay guys, we're going to look at the sort of trickier type of volume and total surface area questions today. There's only really two things that can be super tricky about volume and total surface area. Do you know what? I lie, there's three things. Sorry, there's three things that can be tricky. The first of the three tricky things is if you are given a scenario where you have a container that doesn't have a lid. So basically that just means, usually, let's do a cylinder. Usually we would have a cylinder like this, and then let's say they asked us to determine the total surface area of the cylinder. It would be 2 times the area of the base plus the perimeter of the base times height, right? That's the formula we would use to determine the total surface area of this cylinder. Now, what this actually is, if we actually unpack what this is, this part, 2 times the area of the base, that is now including in the total surface area of this shape, that is the area of the top and the area of the bottom. And in this section here, let's color code, this section here, the perimeter of the base times the height, that's the area of the walls of the container, okay? So when we talk about something that doesn't have a lid, okay, that means we've removed the top half here. That's what's going to happen. So if a container doesn't have a lid, let's actually break it up into two. Let's see how it affects the total surface area and how it affects the volume. Okay, so if an object has both of its lids, we've seen this. Okay, so we're going to say if it has both lids, then we know that the total surface area formula is 2 times the area of the base plus the perimeter of the base times the height of the object, right? The height of our prism. Now, if we remove one of these, remember the red that I've colored in, the top and the bottom, that is taken care of by this 2 times area of base. So if I take the lid off, do you agree with me? I now no longer have 2 bases, I only have 1 base. So if I've taken off my lid, in which case I only have a bottom, so if there's no top, okay, so no top or no lid, then our total surface area formula actually changes. So then instead of saying 2 times the area of the base, that's top and bottom, that's what the 2 is, we're only doing bottom, which is going to be 1 times the area of the base, plus the perimeter of the base times height. Okay, and then our third option, this very, very seldomly comes into play, but the third option is if you don't have a top or a bottom, so that would be like a toilet paper roll. Okay, no top or bottom, just the sides. In that case, we would have no lids, right? So it would be 0 times the area of the base, and 0 times anything is 0. So this whole term would fall away, and our total surface area would just be the wall around the outside of the container. So there, if we had no top or bottom, okay, then the total surface area formula becomes just that bracket, and if we've only got the bracket, then we don't need to put it in brackets. So it would just be the perimeter of the base times the height. Okay, so these are the 3 scenarios. Either you have both lids, top and bottom, or you've got only top or only bottom, or you've got neither top nor bottom. Okay, I'm actually just going to use my spaghetti tin for this. So the total surface area for the spaghetti tin, if I remove its lid, okay, with the lid on, we would use this formula, 2 times the area of the base, that's the area of the top, as well as the area of the bottom, as well as the area of the walls. Okay, but as soon as I remove my lid, I'm now only going to look at the second formula. Okay, I'm interested in the area of the bottom and the area of the walls, but there's no top anymore. So I don't include the area of the top, which is why it's 1 times area of base. Okay, now if we look at volume, remember what total surface area and volume actually mean, hey? So total surface area is basically referring to the space, the area of the outside. So if I were to paint this, the area that the paint would cover. Okay, whereas volume refers to the space inside, the capacity, how much spaghetti can I fit in my spaghetti jar. Now, do you agree with me that if I want to paint the outside of this, removing the lid changes the area that I'm painting, right? I now no longer have to paint this. Okay, so that's why the total surface area changes. But with the lid on, compared to with the lid off, the volume of this container doesn't change. The amount of spaghetti in this container is still the same, right? So the volume is not affected by the fact that I've taken off my lid. So for volume, for all three scenarios, the volume formula stays the same. The volume, regardless of whether there are lids or not, is always equal to the area of your base times height. Okay, this is true all the time, regardless of whether there are lids or not. Okay, so I'm just going to write here, volume formula stays the same regardless of lids. Okay, so regardless of whether we have a lid, or if we have two lids, or if we have no lids, the volume formula is always the same because I can always fit the same amount of spaghetti in my tin, even if I take the lid off. Okay. Yeah, so that's basically it for volume and total surface area when you're talking about a container without a lid or that's missing an end. I'm going to pause you there, erase this, we'll do one example of it, and then we'll go on to the second tricky type of question. Okay guys, so here's our question. We've got a farmer who uses a large cylindrical silo to store his grain, and he wants to, okay, so they've given us a diagram of the silo, so it's a cylinder shape. They tell us that it's 10 meters high and that the bottom of it is 10 meters wide, so basically the diameter of our cylinder is 10 meters. Okay, yeah, then they say, question A, he wants to paint the walls of the silo, and 1 liter of paint covers 1 meter squared. How much paint will he need? Okay, so first off, whenever they talk about the walls of something, they're talking about surface area, okay? Whenever they talk about painting the outside of something, or covering the outside of something, or constructing something out of cardboard or paper, they're talking about the surface area of that prism. Okay, so he wants to paint specifically the walls of the silo. Now, for those of you that don't know, a silo is basically a huge cylindrical, I mean, you can see it's 10 meters across and 10 meters high. They're actually normally larger than that. It's basically a huge cylindrical structure made out of bricks. Normally, you'll see them on farms. Farmers keep grain and mealies and cow feed and all that sort of thing in them. Yeah, so when it talks about the walls of the silo, it's specifically talking about the cylindrical part that comes up. Silos don't have any lids on them, but even if it did have a lid, they haven't said they want to paint the lid. They just want to paint the walls. Okay, so of this, we just want to paint the walls. We're not interested in painting the top of it. In fact, there is no top. If we tried to paint this, we would just fall right in. And we can't paint the bottom because the bottom is on the ground, okay? It's got foundation. It's built onto the ground. So for this, we are looking at one of those scenarios where we have a lidless container. And not only do we not have a top lid, we're also actually not interested in painting the bottom lid. We only want to paint the walls around the outside. Okay. So this is actually a two-part question because they haven't asked us to determine the surface area. They've actually asked us how much paint does he need. So 2 parts. First thing we need to do is find the surface area of the walls. When we have the area that we need to cover, then we can determine how much paint we need. Okay, so starting off with the surface area of the walls. Okay, so usually total surface area equals 2 times the area of the base plus the perimeter of the base times the height of our prism, right? But I don't have a top base, so that becomes 1 times the area of the base. I also am not going to paint the bottom of my prism, so this becomes 0 times the area of the base. And 0 times anything is 0, which means this whole term goes away. Okay, and we're only dealing with that second term. So to find the total surface area of that cylinder then, it's just equal to the perimeter of the base times height. Now the perimeter of a base, our base here is a circle, right? The perimeter of a circle, I hope you remember this, is 2 times pi times radius. So the total surface area is 2 pi r times height, We've taken the perimeter of our base, remember this from the previous lesson, and we've changed that to the perimeter of a circle, which is 2 pi r. Okay, now we can substitute our values in. So 2 times pi times the radius. We know the diameter is 10, which means the radius must be 5, half of the diameter. So it's 2 times pi times 5 times the height of our cylinder, which is 10. And we go and plug that in our calculator. I don't know where my calculator is. Hang on, sorry. I'll be right back. Okay, I found it. Okay, so it's 2 times pi times 5 times 10. And we get 314, 15. Okay, I think a lot of us are struggling with rounding, so I'm gonna just write down all of this, 2654, and remind you how to round off. So remember, we round to 2 decimal places. In order to do that, you look at the value of the third decimal. If the value of the third decimal is 5 or higher, okay, then the second decimal goes up. So that's what we've got here, right? That is 5 or higher, so the second decimal must go up. But if our third decimal was 4 or lower, okay, then the second decimal stays the same. It never goes down. I think some of you might have thought to yourself, goes down. It never goes down. It either goes up or it stays the same. So in this scenario, our third decimal is a 9. That is higher than 5. That means our second decimal, this 5, must go up to a 6. So that means that this is equal to 314,16. And now watch your units. Remember volume. Wait, what are we doing? We're doing total surface area. Total surface area is measured in units squared. So it's meters squared. Let's quickly write that in our heading again, just to remind ourselves. Volume is measured in units cubed. Total surface area is measured in units squared. I can't remember if I did this in the basic TSA and volume lesson or in the summary lesson. So if I haven't said this yet, I'm sorry. Okay, volume, units cubed, total surface area, units squared. Okay, so we now have the total surface area. We've done the first of the 2 steps. Now how much paint do we need? Well, they tell us that for every 1 meter squared, we need 1 liter of paint. Which means if we've got 314,16 meters squared, we need 314,16 liters of paint. Okay. So it's 314,16 liters of paint. Okay, now question 2. I'm just going to divide my page a bit so I don't get confused. Question B rather, sorry. What volume of grain can fit in the silo? Okay, volume. They want to know how much grain. If they didn't use the word volume though, they could have used the word capacity. They could have said, what is the capacity of the silo? That means the same thing. Okay, so volume, capacity, same thing. So what volume of grain can fit in the silo? We're looking for the volume of that cylinder. The fact that it doesn't have a top doesn't affect how much grain can fit in, right? So we're just going to go ahead and use the normal volume formula. Volume equals area of base times height. Our base, we've already identified our base is a circle. So when we expand this formula, we do it for a circle. The area of a circle is pi times radius squared, and then we must times that by height. Okay, so when we sub in here, volume is equal to pi times our radius. We already spoke about this, must be 5, right? If the diameter is 10, the radius must be 5, half of the diameter. So it's pi times 5 squared times the height of our prism, which is 10. And we go and put that in our calculator, and we get pi times 5 squared times 10. Just quickly note how I've typed it in. Oh my goodness, I don't know if you guys can see that. I haven't just written pi and then 5 squared immediately afterwards. If you do that, you're going to get an error on your calculator. You must put a times sign between your pi button and whatever is next to your pi button. Okay. Okay, and we get 785 785,40 meters cubed. Remember, volume is measured in units cubed. So we can fit 785,4 meters cubed of grain in this cylinder. Okay, so that's it. Yeah, that's the first tricky type of question. So here, just a quick reminder, why was it tricky? It was tricky because when we painted the cylinder, we did not paint the top or the bottom. So it affected our total surface area calculation, but it does not affect the volume of your shape. Okay, so that's the first type of tricky one. Oh my word, it's so out of focus. Sorry. Okay guys, so the second type of tricky question would be one where they require you to work backwards. Now I know you've already seen some of these. Actually, I don't know about the other classes. Definitely 8FO and 8CO have seen some of these, where you are given the area, or you're given the total surface area or the volume, and you are asked to work, sorry, my cat jumped on the table. You are asked to work backwards from that to determine what some of the dimensions of the shape. Okay, so that's what we're going to look at here. So firstly, what actually is it? It's when you are given the volume or the total surface area, and you are asked to determine a dimension. So what I mean by a dimension is they might ask you, what's the radius of the base of this cylinder? Or what's the length of the side of this rectangle that is the base of a rectangular prism? Okay, something like that. And the way you actually go ahead and answer it is you start almost exactly the same as you normally would. Okay, so you start, okay, so to answer your method, you're going to start the same as usual. You're going to write your formula. Okay, and as usual, then you are going to substitute in what you know. Okay, but now once you've done that, you're going to see that what you have isn't a nice little expression where you have the thing that you want equals a whole bunch of numbers and you can just go and put that in your calculator. It's not going to look like that. You're going to have something that more resembles an equation where you do know what's on this side and you know some of the things here and you don't know some of the things here, and you're going to have to solve it like an equation. Equal sign in the middle, you rearrange this so that you isolate your variable and you solve for whatever your unknown is. Okay, that's the plan. So you substitute in what you know and then you solve it as an equation. Okay, and it can be a little bit easy and it can be a little bit tricky, especially when you get to the higher grades. Okay, so I'm going to pause you there. You obviously also pause if you haven't finished writing it down, and then we're going to do an example. Okay guys, so we're going to do two questions for this. So looking at example 1 first on the left hand side, they tell us that the total surface area of that cube underneath it is 96 centimeters squared, and they ask us to determine the side length. Okay, so they've told us that the total surface area of this cube is 96, and now they want to know how tall is it. Okay, so we're going to start off like we normally would. We'll write our formula. Total surface area equals. Now let's check. Anywhere have they indicated that this is missing any lids? No, they haven't. So it's normal total surface area question. So it's 2 times the area of the base plus the perimeter of the base times height. Okay, next thing we would do is identify the shape of our base, and from that expand our formula so that the area of the base and the perimeter of the base, we're using the correct formulas for that specific shape. So they've told us it's a cube. Okay, which means every single side of our shape, every face of this shape is the same, and they're all squares, so it doesn't really matter which one you use. I'm just going to use this one in the front. So that's going to be my base, and it's a cube, right? Which means if that's S, then that's also S, right? And that's also S. A cube has the same dimensions in every dimension. Okay, so when we expand this, so that we've got total surface area equals 2 times the area of a cube is side squared, right? Some of you might use side times side. Oh dear. Okay, we're going to carry on. I think I might have given you a grade 9 question, but we're going to carry on. Okay, plus The perimeter of our base is 4 sides, okay, 4 times the sides, times the height of our shape is also S for side. Okay, no, this isn't a grade 9 question, you can do it. Okay, then now let's actually go and substitute in what we know. We know that the total surface area is 96. 2 times, we don't know S, we have to just keep it S, plus we don't know S again, we have to just keep it S. Okay, so we've substituted everything that we know, which is basically just the total surface area. And now I know it looks ugly, but we're going to neaten it up and it won't look so scary. But now this is basically just an equation, right? Where we have some constants and we have some letter S's and we have to solve for the letter S. Okay, now looking here, 2 times a letter, better way of writing that is just 2s squared, right? So let's go ahead and do that. That'll be much neater. 96 equals 2s squared. Then, inside the brackets here, 4s times s. Remember, when you multiply things with the same base, you add the exponents, and those both have an exponent of 1. So we're going 4 times coefficient 1 is 4, so this is plus 4. S to the 1 times S to the 1 is S squared. Okay, now we can add these two like terms, right? S squared and S squared are like terms, so we can add them. So we're going to have 96 equals 6S squared. And now this kind of looks a little bit like Pythagoras, except the first thing to do is we actually have to get rid of the 6. So remember, to get rid of the coefficient of a variable, you divide both sides by the coefficient. So we have 16 on the left-hand side, and on the right-hand side, 6 divided by 6 cancel, and we've just got our s squared, which is perfect. That's why we divided by 6. And now remember, with Pythagoras, we're going to do the same thing we did there. You don't want s squared, you just want s. So to turn that back into s, we do the opposite of squaring, which is to square root. Okay, we're going to square root both sides, and we're going to get that s is 4 centimeters. Okay, square root of 16 is 4. How did I know it was centimeters? Because they gave me my cube's surface area in centimeters squared, which means the side has to be 4 centimeters. Okay. And yeah, that's example 1. Okay, and then example 2 on the right-hand side, they tell us that the volume of that prism is 72 meters cubed, and we need to determine the length of the side marked X. Okay, so let's have a look. We've got a triangular prism, right? That's our base, triangle, and the height of it is this X. Okay, so let's actually, I always like to do that beforehand if I'm just doing a question myself. Identify the base, it's a triangle. Okay, and that is our height, h, which in this case is x. We don't know how high it is, we just know it's an x. And they actually want us to determine the length of the side marked x. So we look, what are they talking about? They're talking about volume, so we're going to use the volume formula. Okay, V equals area of base times height. Now we're going to expand on this depending on the shape of our base, so that the area of our base is expanded into a nice formula. So when we expand that, our base is a triangle. Now I don't want to confuse you. Some of you use this formula, half base times height. Some of you might use base times height over 2. Some of you might have been using something with that symbol in it. That just means perpendicular height. Okay, I'm going to use this one, but it doesn't matter which formula you use here, it'll still work. Okay, so when I expand area of base, that's the way I do it. So that becomes half times base times perpendicular height times the height of our prism. Okay, now we're going to go ahead and substitute in what we know. Now we know the volume is 72, so where we see V, we're going to put a 72. Half. We do know the base. We know the base and we know the height, right? So looking at our triangle, we know that that's 3, that's 4, and that is 5. Remember, for the base and height of your triangle, you need to use the two sides of your triangle that form the 90 degree. In other words, the two sides that are not the hypotenuse. So in this question, the hypotenuse is 5, so we don't want to use 5, we want to use the other two, the two that form the 90 degree. So it's going to be 1/2 times 3 times 4 times the height of our prism is x. Okay, so now let's go ahead and simplify this. 72 equals 1/2 times 3 times 4, that's what this means, right? So 1/2 times 3 is 1.5, and 1.5 times 4 is 6. Yeah, so I've got 6 times x. Okay, now remember, a number times a letter can be written as just the number next to the letter. Now we know how to solve this. I want to get the x by itself, so I divide both sides by the coefficient of x, and I get what's it, 12? 72 divided by 6? 12. We get that x is equal to 12 meters because the volume was in meters cubed. So this is 12 meters. Okay, so a little bit tricky. The tips here are look what is given to you. So they gave us total surface area. That's what made me know I must use the total surface area formula. I expanded, substituted what I knew, and then solved for my unknown. Same thing on both sides. Okay, you choose the formula that you think you need to use based on what's given in the question. So here I used TSA because they gave me TSA. Here I used volume because they gave me volume. Then you expand according to your specific prism, substitute in what you know, and then solve it like an equation. Okay, so I'm hoping you guys are starting to realize how important equations are. It comes up everywhere. Okay guys, and the third type of tricky question that you might get is one where you have a composite based prism. So remember, your regular prisms are a rectangular prism, a cube, a triangular prism, and a cylinder. So anything that is not one of those is a composite based prism. Now to deal with these, there are steps. You're just going to have to follow these steps every time. Okay, so in order to answer questions like this, the first thing you do is you write the formula for what the question is asking. So if the question is asking for volume, you write your volume formula. If the question is asking for total surface area, you write your TSA formula. Okay, so write appropriate formula, either the volume or the TSA. Okay, so either volume or total surface area. Sorry, my neighbors are being loud. Okay, so you write your appropriate formula depending on what the question is asked. Once you've done that, you need to then go ahead and look what do you know and what do you not know. Because for these formulae, we need the area of our base, and for TSA, we also need the perimeter of the base, right? Now, our base is a composite shape. Remember a composite shape? I'm hoping we remember this. A composite shape is one where you've got two or more shapes stuck together or cut out from one another. So for example, I've got a square with a semicircle stuck to it. So that's now a composite shape. Or I've got a circle with, let's do a weird one, a semicircle cut out of it. Something like that. Okay, now any weird composite shape you can think of, that can be turned into a prism. Okay, so I could take this, let's make a smaller one. Let's say I had a circle with a circle cut out of its center. I could take this and say, well, now what if I've actually got a cylinder that's had a circle cut out of its center? Oh, sorry, that should be solid. So I've basically taken a cylinder and I've cut a hole through the middle of it. Okay, like that. So I'm not really good at drawing, but you do understand what I'm saying. So I take a cylinder and I cut a hole through it. Or I take a rectangular prism and I stick a semicircle prism on top of it. Okay, something like that. Kind of like a loaf of bread on its side. Okay, so that's what we're talking about here, where your base is now a weird shape. So if your base is a weird shape, we don't have formula for those. Okay, remember when you've got a composite shaped base, there's no area of a circle with a semicircle cut out of it formula. You have to logic that out yourself. You have to use your understanding of composite shapes to work that out. So step 2 is to determine the area of your base, and if you need to, so if you're looking for volume, you only need the area of your base. If you're looking for total surface area, you need both. Okay, so determine the area of your base and the perimeter of your base using composite shape methods. Okay, now if you don't know how to do it using composite shape methods, that's a really good point. I actually will upload the video explaining how to do area of a composite shape and perimeter of a composite shape. I'll upload that video as well to the Teams thing. Okay, so we're going to determine the area and the perimeter of the base using composite shape methods, then substitute in those values. Okay, so once you've determined the area of your base and the perimeter of your base, you substitute those values into those formulae depending on what the question wants. You stick it in your calculator, you get your answer. Okay, so it's only 3 steps, but I promise you when you do it, it seems like a lot more than 3 steps. It is a tricky question, so I'm going to go ahead and pause you there. We'll do an example. I think maybe we should do 2 examples of this. Come on, pause. Okay guys, so here is example 1. We're going to determine the volume of this weird looking shape here. Okay, so what we have is we've got a cylinder that's basically had a hole drilled through it. Okay, and we need to determine the volume of that shape. So excluding the hole drilled through it. Okay, the only thing I can think is you get those fancy... Let me actually look around the house to see if I cannot find something that I mean. Okay guys, this is the best I can do. Okay, so when I talk about the volume of this shape, I'm talking about the volume of this shape within its walls. Okay, so it's got outside walls around the outside, and then it's got another inside wall. So I want to know what can fit between the outside and the inside walls. So I know it's not a great example, but this Omo bottle has a, can you see this? Okay, so it's got a hole here in the middle, right, the handle. Now, when you talk about the volume of this Omo bottle, I'm not talking about the volume of the hole. I'm talking about the volume of what can fit inside it, including what can go up in the handle, because there is liquid in this handle. But we're not talking about the volume of the hole. Okay, so that's basically what we're doing here. We're talking about the volume of the container, not the volume of the hole. Okay, now I've lost all my pens. There we go. Okay, so we're doing volume. So first thing we do is write the volume formula. Volume equals area of base times height. Step 2 is to determine the area of your composite base and, if necessary, the perimeter. Now in this question we don't need the perimeter, we only need the area. So step 2 is to find the area. Now the area of our base, let's actually rather just do it as a heading. First we find the area of our base. Now our base, I like to do this, you don't have to, but I like to actually draw my base so I can see what I'm dealing with. My base is a circle with a circle cut out, right? So I'm looking for the area of this shaded part. Okay, that's the area of my base. And I know, they've given me in the diagram, that the diameter of my base is 8 centimeters. So from there to there is 8 centimeters. And they've also told me the diameter of that inside section is 3 centimeters. Okay, so remember the way we would have done this? I don't know if this is the way your teachers have taught you, but the way that me and my class do it is we break this into the parts that make it up. So we've got 2 circles. So I'm going to call this one circle 1 and the small one circle 2. So we're going to determine the area of each of those and then subtract the area of circle 2 from that of circle 1 because circle 2 has been removed from circle 1. The small circle has been cut out of the big circle. So we're going to subtract its area. Okay, but I'm getting ahead of myself. Starting off with circle 1, we go area of circle 1 equals. Area of a circle is pi r squared. So that's going to be pi times the big circle has a diameter of 8 centimeters, which means its radius is 4 centimeters. So it's pi times 4 squared, which is pi times 4 squared, 50,27 centimeters squared. Okay, we're going to do the same thing, but now for the small circle. So the area of circle 2 is pi r squared, which is pi times. Circle 2 has a diameter of 3 centimeters, which means its radius is 1.5 centimeters, right? So it's pi times 1,5 squared, which is 7,07. Okay, so now to find the total area, the area of our base, we're going to say that's the outside circle minus the inside circle. Okay, so it's the area of circle 1 minus the area of circle 2, which is 50,27 minus 7,07, which is 43,2. Okay, so all of this was just step 2. Step 1, write the formula. Step 2, determine the area of your base. Step 3, substitute that into that and solve. Okay, so step 3, the volume is then equal to the area of the base, there it is, 43,2, times the height. The height of our shape here is 10 centimeters. And that is 432 centimeters cubed for our answer there. Okay, so a little bit tricky, but really if you just break it into the different parts, if you've been understanding so far, if you know all your formulae and you've been focusing on the lessons and you know all of your methods, then this actually isn't that tricky. Okay, so I'm actually going to do a second example. I know this lesson is getting a little bit long. After the second example, we're done, I promise. Okay guys, so example 2, we need to determine the total surface area of this shape here. Okay, so we see TSA, we write TSA formula. Step 1, write the formula. Total surface area equals. Anywhere does it say there's no lid? No, it's open everywhere. There's no hint, there's no implication anywhere that this is a scenario where you don't have a top or a bottom or both. Okay, so it's a complete closed shape. So total surface area is 2 times the area of the base plus the perimeter of the base times height. Okay, step 2 is to determine the area of the base and the perimeter of the base. Okay, so let's go ahead and do that. Area of the base. Now, just like in the previous question, I'm going to draw my base so I can actually see what I'm dealing with. Remember, with prisms, your base is always the shape that is not a rectangle, unless it's a rectangular prism, in which case you can pick whichever side you want to be your base. Okay, so looking at this shape, the irregular side basically is this here, right? Okay, so if I draw that again, I've basically got something like a square with a triangle stuck on top, kind of like that. Okay, that's what I'm dealing with. Now let's see what we know. We know that this whole side is 7. We know that that is 4. We know that this is 4. And we know that this is 5. Okay, so first off, finding the area of our base. Let's see what we've got. Our base is being split into a square and a triangle, right? Okay. So let's go for it. First off, looking at the area of the square. The area of the square is side squared, which is 4 squared, which is 16. Okay, now we're going to do the same thing but for our triangle. Area of a triangle, the formula is half times base times height, which is half times. Remember, your base and your height are the two sides that make the 90. Now our 90, because, okay, some of you might have started linear geometry, some of you might not have. Those of you that have, you know that the interior corner of a square is 90 degrees, right? and you know that this is a straight line, and that together must add up to 180 degrees because it's a straight angle, which means that is also a 90-degree angle. Okay, so in our triangle here, that's our 90-degree angle. So when I substitute in for my base and my height, I want the two sides that make the 90. And the two sides that make the 90 are that side and that side. This side I don't know. It's a portion of 7. This side I also don't know. Okay, so we got to try and figure this out now. Okay, we know this whole thing is 7. And that's 4, so we know that section of it is 4, which means this section of it must be 3, right? The 4 and the 3 together must make the full 7. And here, this is a square, and the opposite sides of a square are equal, so if that's 4, then this side must also be 4. Okay, so we have our base and our height. So it's a half times 3 times 4, which is 6. You can put it in your calculator to work that out if you're not sure. Okay, and let's go for it. So the total area, the area of my base. Now let's look. We don't have a cut out type shape. We've stuck two things together, right? So we've got a square with a triangle stuck to it. So we're increasing our total area, which means it's going to be the area of the square plus the area of the triangle. So I've got 16 plus 6, which is 22 centimeters. Is it centimeters? Oh, we haven't got any units here. Okay, 22. Okay, so that's the area of the base. Now we're not done yet. We can't start back in yet because we also need perimeter here. So perimeter of base. Now remember your perimeter, you just walk around the outside of your shape and you add all of the values, okay, of the outside of your shape. So the outside, I'm really running out of colors here. So the outside of your shape is the actual outside. Okay, we are not walking through the middle here. We're walking around the outside. So for the perimeter, it's going to be this long side, the bottom, the side, and then the slopey little top here. Okay, there's 4 sides we're adding together. So for the perimeter of the base, we're adding together side 1, side 2, side 3, and side 4. Okay, you do not have to show the side 1, side 2, side 3, side 4 thing. You can go straight into the values if you prefer. Okay, so when I put my values in, that means I'm going 7 plus 4 plus 4 plus 5, which is 12, 20, is that right? 8 and 7, yeah, that's 20. So the perimeter of our base is 20. So now we can go and put this all into our total surface area, and determine the total surface area. So TSA equals 2 times the area of the base is 22 plus the perimeter of the base comes next to it, that's 20, times the height of our shape. Oh, I have forgotten that. Sorry guys, I forgot that in the question. Okay, let's say that it goes 3 in that way. So it's 20 times 3. Sorry about that. And when we do that, we've got 44 plus 20, plus 60, which is 104 units squared. Okay, if they don't tell you the units, like in this question, then you say units squared. We don't know what the units are, so units squared. Okay, that's it. This was quite a tricky one. This is definitely something you're much more likely to see in grade 9, but it definitely also can be asked as a level 4 question in grade 8. Okay, yeah, that's it. Please do remember that you can ask your teachers still for help. You can still go onto the Teams meeting for consolidation to ask questions. Yeah, guys, just keep chatting to us. Let us know when you need us, please.